We want to take a look at the trigonometrical ratios of angles between 0 degrees and 360 degrees. Before we continue, let's take a quick recap of what we have learned so far. We have learned about the quadrants. That we have 4 quadrants: the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. In the first quadrant, the values of theta ranges from 0 degrees to 90 degrees. So therefore we will have 0 less than x less than 90 degrees. Likewise, in the second quadrant, the values range from 90 degrees to 180 degrees. So we have 90 degrees less than x less than 180 degrees. Similarly, in the third quadrant, we have the values of x ranging from 180 degrees down to 270 degrees, or let's say theta. Now let's be using theta ranging from 180 degrees less than theta less than 270 degrees, and finally this will be 270 degrees less than theta less than 360 degrees. Now we understand the concept of the relative acute angle, where x here is the acute angle, which is theta. X, the acute angle here, will be 180 minus theta. X as the acute angle in the third quadrant will be theta minus 180 degrees, and x here will be 360 minus theta. So let's now consider the trigonometric ratios between 0 degrees and 360 degrees. But then before we continue, I want to introduce you to something very important, which is called SOHCAHTOA. SOHCAHTOA. So here means sine is equals to opposite divided by hypotenuse, and here means we have the cos being the adjacent divided by hypotenuse, and here we have the tangent being the opposite divided by the adjacent. Now the opposite will be the side. The opposite will be the side facing the angle. The hypotenuse will be the longest side, and the adjacent will be the last side. Since it is a triangle, a right angle triangle. Now let's take an example just to illustrate this. We have a right angle triangle with angle theta. This will be my opposite because it's the side which is facing the angle. The longest side will be my hypotenuse, and the last side will be the adjacent. In the same way, if you have something similar in this direction, theta, and this we will say is the shortest side. Okay, sorry, the side facing the angle, opposite, the longest side, hypotenuse, and the other side, which is the adjacent. Now we want to involve SOHCAHTOA into trigonometric ratios between 0 degrees and 360 degrees. Now we want to make this very detailed for ease of understanding. Now we have a Cartesian plane. The Cartesian plane shows this is the positive x-axis and the positive y-axis, the negative x-axis, and let's call this the negative y-axis. And in the Cartesian plane, we have various points in the graph. We have, let's call these points P, Q, R, and S. Point P, or let's start with point Q. Okay, point Q is such that it has positive X and it also has positive Y. Point Q is such that it has negative X but it has positive Y. Point S is such that it has negative X and also negative Y. Point R is such that it has positive X and negative Y. They are all lines, so we can use dotted lines to illustrate their connectivity. Using dotted lines, we can say this is the point of negative X, this is the point of positive X, positive Y, and negative Y. So let's draw a line now to represent each. Let's begin with the first quadrant. The first quadrant. Remember, in the first quadrant, the acute angle represented in the first quadrant is x is equals to theta. Just like we have here, x is equals to theta. So we say the acute angle here is simply theta. The length here, from here to here, from the origin to this point is x. The height is also y. So now we can make our expression for sine, for cos, for tan using the expression of SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now sine now is what? Is opposite over hypotenuse. Before we proceed, let us look at what is our opposite, what is our hypotenuse, and what is our adjacent. Our hypotenuse is unknown, but then the opposite is the side facing the angle, which is simply y. So we have our opposites to be equals to y. The adjacent is the other side, which we'll call x. Now let us tag our hypotenuse to be equals to r. So this will be equals to r. So if sine is opposite over hypotenuse, we'll allow it to give us y, which is opposite over hypotenuse, which is r. Cos now, remember it's a sine theta because we are taking the sine of this angle. So cos theta now will be, no, we are using SOHCAHTOA. Let's write it here. SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Cos, which is adjacent over hypotenuse, the adjacent in this case is what? X. The hypotenuse is r. Tan theta is opposite over adjacent. The opposite is what? Y. And the adjacent is x. This is for the first quadrant. Let's move on now and let's deal with the second quadrant. Is a point P going to the origin. Remember, it is a right angle triangle, and this time, what is the acute angle representing points for second quadrant? We go back to our expression or summary, we will understand that the acute angle for the second quadrant is 180 minus theta. 180 minus theta. So let's do that. So we call this 180 minus theta. The opposite to this is positive y. The adjacent is negative x. and we'll just call our hypotenuse r. So let's rewrite it. Opposite is y, adjacent negative x, and hypotenuse is equals to y r. So let's begin with sine 180 minus theta. Sine 180 minus theta here means we are dealing with sine is opposite over hypotenuse. Opposite over hypotenuse. The opposite is y. The hypotenuse is r. Similarly, cos is 180 minus theta, which is cos is adjacent over hypotenuse. Adjacent divided by hypotenuse. So that means we have minus x divided by r. And finally, tan 180 minus theta is simply opposite, because tan, so katua, we have tan here, is equals to opposite over adjacent. And the opposite in this case is y. The adjacent is minus x. Now we are done with the second quadrant. Let's move on down to the third quadrant. The third quadrant, point S, has the acute angle of theta minus 180. Theta minus 180. The opposite to this is y, which is in the negative direction, that's minus y. And the adjacent is simply minus x. And we have the hypotenuse to be r. So let's rewrite it. Opposite is equals to minus y. Adjacent is equals to minus x. And hypotenuse is equals to r. So let's begin. Sine theta minus 180. We evaluate for cos theta minus 180, and also for tan theta minus 180. Remember that sine is opposite over hypotenuse. The opposite is minus y. The hypotenuse is r. Minus y over r. Cos is adjacent over hypotenuse. The adjacent here is minus x. The hypotenuse is r. That's minus x divided by r. And tan is opposite divided by adjacent. The opposite in this case is minus y. The adjacent is minus x. Minus y divided by minus x, and this will give us y over x. Now let's take the last phase. The last phase is the fourth quadrant. In the fourth quadrant, we have the acute angle to give us 360 minus theta, just as we have here. 360 minus theta. Now, in this case now, we have our opposites, which is the line facing the angle, to be minus y, because it's in the negative direction. Similarly, we have our adjacent to be x, and our hypotenuse is r. So let's rewrite. Our opposite is equals to minus y, our adjacent is equals to x, and our hypotenuse is equals to r. So we will evaluate for sine 360 minus theta. We evaluate for cos 360 minus theta, and we evaluate for tan, so 360 minus theta. Sine is simply opposite over hypotenuse. The opposite in this case is minus y. The hypotenuse, let's move this. the hypotenuse is R. Cos in this case is adjacent over hypotenuse. Adjacent is simply x, because we have here x, and the hypotenuse is R. And also the tan is opposite over the adjacent. The opposite is minus y, the adjacent is x. Now I want you to observe something here, that all sine theta in the first quadrant. Now let's look at the first quadrant. The first quadrant here, sine theta is positive, cos theta is positive, and tan theta is also positive. Now let's move to the second quadrant. In the second quadrant, sine theta, or sine 180 minus theta, is positive, cos 180 minus theta is negative, and tan 180 minus theta is negative. So only sine is positive. In the third quadrant, we can see that sine theta minus 180 is negative, cos theta minus 180 is negative. However, tan theta minus 180 is positive. So only tan, okay, let's write it, only tan is positive. And here we have that only sine is positive. Let's put that in mind, and let's move on to now to the last quadrant, which is the fourth quadrant. In the fourth quadrant, sine 360 minus theta is negative, cos 360 minus theta is positive, and tan 360 minus theta is negative. So here we are saying that it is only cos that is positive. Now we want to draw an inference from this. Drawing an inference from this, let's create another diagram to establish understanding. We have four quadrants. But let's begin with the first quadrant. In the first quadrant, we have that the acute angle is x is equals to theta. So if the acute angle is x is equals to theta, we understand fully from here that sine theta is positive, cos theta is positive, and likewise tan theta is positive. Let's move on to the second quadrant. Second quadrant, the acute angle in this case here is 180 minus theta. So we can write this for the second quadrant, that sine 180 minus theta is what? Is equals to sine theta, which is an acute angle, and we will call this what? This is positive. Cos 180 minus theta is equals to, okay, let's rewrite the order. Sine 180 minus theta is positive, cos 180 minus theta is negative, and tan 180 minus theta is also what? Negative. Moving on, let's go to the third quadrant. where the acute angle x is equals to theta minus 180 degrees. So we are saying that sine theta minus 180 degrees, according to the diagram here, is negative. Cos is also negative. Cos, we have negative. Cos theta minus 180, negative, and tan theta minus 180 is positive, because only tan is positive. And finally, we move to the fourth quadrant. And in the fourth quadrant, the acute angle is x is equals to 360 minus theta. So where we say that sine 360 minus theta is what? Negative. As we can see here, sine is negative, cos is positive, tan is negative, because we know that only cos is positive. So we can draw the inference that sine 360 minus theta is negative, cos 360 minus theta is positive, and tan 360 minus theta is negative. Now let's draw an inference now. Here all are positive, here only sine is positive. In the third quadrant, we have that this is only tan that is positive, and in the fourth quadrant, only cos is positive. So the inference here, it's simple. If you draw a short one, all is positive here, only sine is positive, tan is positive in the third quadrant, and c is positive in the fourth quadrant. So this is the way I was taught. We take the first quadrant A, the second quadrant S, the third quadrant T, and the fourth quadrant C. And we just say all. We say all students take coffee. Another way people do is we start with the fourth quadrant, go into the first, and just say simply cast. But then I prefer from the first to the second, third, and fourth, and say all students take coffee. Now we have established a fact that all trigonometric ratios are positive in the first quadrant, only sine is positive in the second, only tangent is positive in the third, and only cosine is positive in the fourth quadrant. Now let's see how that applies when we take numerical examples.